Hey, this is Leah Applegarth, and I am going to go over your Chapter 2 test review with you. For numbers 1 and 2, we're going to predict the next number in the following sequences. Now, one thing that we've done here in the past is put what we add to each one to get to the next one and see if we can find a pattern from there. So the first one we added 2, the next one we added 4, the next one we added 6. So we can predict that the next one we're going to add is 8, and 16 plus 8 is 24. And then the next one we add to that is going to be plus 10, and 24 plus 10 is 34. Awesome. Okay, so the next one we're looking at is 200, 150, 25. And we can see these numbers are decreasing. It decreases by 100, and then by 50, and then by 25. So if you look, I can see that the pattern is that we're going to divide by 2 each time. So I'm gonna pull up my handy dandy calculator to help me with this, just so you can see I'm not making crazy numbers up. 25 divided by 2 is 12.5, so the next one is 12.5. And then 12.5 divided by 2 is 6.25. Awesome. Okay. So number 3, we're going to write the inverse, converse, and contrapositive for the conditional statement. If the waves are good, that's a hypotenuse, we are going surfing. That's the conclusion, hypothesis and conclusion. So an inverse takes and keeps the order. It just puts the not in front of it. A converse switches the order, and a contrapositive does both. I'm going to get my typing skills going. That way it'll be a little bit neater to watch. So here's the, our inverse is when we put not in front of each, the hypothesis and the conclusion. So if the waves are not good, then we are not going surfing. Okay, so inverse puts the not in front of it. The converse is when we switch it. So if we are going surfing, so then the surfing comes first, then the waves are good. I'll put a period at the end just for my friendly English teacher. Okay, and then the contrapositive switches the hypothesis and the conclusion and puts a not in it. So if we are not going surfing, then we are not, then the waves are not good. Okay, the inverse, converse, and contrapositive. Remember, you guys can always pause this, fill in your notes, fill in the review, write it down. This is a video, so it is at your leisure. Okay. Number 4, find a counterexample for this statement. If angle A is acute, then the measure of angle A is equal to 30 degrees. So what we have to do is find an acute angle that is not 30 degrees. So my counterexample is going to be, how about the measure of angle A is equal to 20 degrees. There we go. It's acute and not equal to 30 degrees. All right, number 5. We are going to determine if the following statement is a good definition. If it's not, explain. Remember that a good definition is true and has a true converse. So when we switch it, it's going to be true. So let's write down the converse and see if it rings true. A rectangle has 4 right angles. So actually, let's write it in conditional form first. So the conditional has an if a rectangle has, if a shape is a rectangle, then I'll put the comma. Then it has 4 right angles. Okay, so let's look at the converse. Okay, if a shape is a rectangle, then it has 4 right angles. If a shape has 4 right angles, then it is a rectangle. I'm thinking of, so if we just look at, I'm up here in my toolbar. If we just look at our different shapes, I can create a rectangle. We'll create one. I like this lavender color. It's my faves. So we can make a rectangle. We look, yeah, it has 4 right angles, but check out what happens with this shape here. We'll make it teal. Does this shape have 4 right angles? Yeah. And is it a rectangle? No. It is a square. I know, I get excited on the counter examples. All right, and when we have a counter example, so we have to say this is not a good definition. Because there is a counter example. My counter example went all the way off the rails here. All right, number 5. Name the property that justifies each statement. So if x is equal to 5 and 5 is equal to y, then x is equal to y. So if you don't remember, the one that has 3 different things, so there's a x, which is 1, a 5, which is 2 items, and a y, which is 3 items. Let me pull up our notes and you can see which one it's going to be. So here's our notes on our properties from 2.5. And the one with 3 items is this transitive property. So we go transitive property. It's the one with 3 items. Now we look here, B says angle B is congruent to angle B. We look back at our notes and we say, which one of these has just the item equal to itself? Oh, that's right here, only 1 item. It's the reflexive property. You guys, I'm hoping you will use your notes as a reference. I'm not asking you to have everything memorized. So this is the reflexive Okay. All right, and then the last one we are looking at is AB is equal to BA. So let's take a peek back at our notes. What is it when we have two items and you can write them as the reverse? That is right here. That is the symmetric property. For some reason, I always have trouble spelling symmetric, but I think I can nail it this time. Boom! Symmetric property. Okay, number 7. We're going to find the value of the variable and the measure of the angle. This is testing to see whether you remember that vertical angles are congruent. Some of you guys may have known this, but just not have remembered it was vertical angles. So this angle is equal to this angle. We're going to go ahead and write that down. 5x minus 10 equals 2x plus 20. And we're going to find the variable and the angle. So we're going to do, we're not going to stop just with x. We're going to keep rolling on until we have also the angle. All right, we have to make a decision. Do I want to subtract 5x's or 2x's? And in this case, I always go with the smaller because it makes my calculations a bit easier. When I minus 2x from both sides, I get 3x's here. I get minus 10, and I get 20 on the right side. Okay, I'm going to add 10 to both sides. And I get 3x equals 30. The last thing I'm going to do is divide by 3. And here we have x is equal to 10. That checks off this box. Now we have to find the angle. So if x is equal to 10, then our angle is 5 times 10, which is 50, minus 10, which is 40. And it doesn't matter which one you do. If you had plugged in 10 here, we would have gotten 2 times 10, which is 20, and 20 plus 20 is also 40. So it's 40 no matter how you slice it. And that's the beauty of congruent angles. Okay, number 8. Find the value of the variable and the measure of the angle. So we know that this is a straight line. And we know that a straight line is equal to 180 degrees. So this angle here plus this angle here is going to be equal to 180 degrees. Oops. Plus. So 4x minus 5 plus 2x minus 1 is equal to 180 degrees. So the next thing that we're going to do is we're going to combine like terms. So 4x's plus 2x's is 6x's. Minus 5 minus 1 more is minus 6 equals 180. Then I'm going to add 6 to both sides because I'm trying to solve for x. 6x equals 186. And then lastly, I'm going to divide by 6. And x is equal to, grab my calculator here, 186 divided by 6 is 31. And then again, this one we're finding the variable, which is x, and the measure. So now we have to go 2 times 31, because we're plugging it in for x, minus 1. 2 times 31 is 62. Minus 1. 62 minus 1 is 61 degrees. Boom and boom. Okay, guys, we're on the last one. Again, if I'm going too fast, feel free to pause, rewind, rewatch. It is your video. You can do whatever you want. Okay, we're going to use the diagram to complete the proof by filling in the steps. So we are going to answer the reasons for all of these little buddies here. We are given this figure, and we're going to fill in the reasoning here. All right, so we look at our first statement here, the measure, and then we're just going to follow. I love to follow with a little line. The measure of ABD, so I go ABD plus the measure of DBC, DBC is equal to 180 degrees. So I'm going to throw down here that this is the linear pair postulate that says if two angles form a linear pair, then they are supplementary, and to be supplementary means to add up to 180 degrees. So that is true in this case. So now we got 4x minus 5 plus 2x minus 1 equals 180 degrees. What do we call it when we take out something and replace it with something that is equivalent? Oh, we call that substitution property. Let's go ahead and spell that right. Substitution property. Okay, then we got 6x minus 6 equals 180. What happened here? Oh, they combined like terms and simplified. So we're going to go ahead and put, you can put combined like terms. Simplify is also acceptable. Okay, 6x equals 186. What happened between here and here? Something happened to this minus 6. Oh, well, we added 6 to both sides. And what is it called when we add something to both sides? Well, that is the addition property of equality. And then something happened between here and here. It was 6x equals 186, and now it's x equals 31. So we must have divided by 6. And 186 divided by 6 is 31. What is it called when we divide both sides of an equation? Oh, that's the division property. Not too hard, right? And then it says measure of angle ABD is equal to 119. What had to happen in order for that declaration? Oh, we must have plugged in 31 for ABD. We must have said, well, ABD is 4x minus 5, so we must have done 4 times 31 minus 5 to get 119. What is it called when you take something out and put something equivalent in its place? Oh, that's called substitution. All right. And that concludes, ladies and gentlemen, the Chapter 2 test review. Thank you for hanging with me, and we will talk to you soon. Let's get our secret phrase. Let's make the addition property our secret phrase. So if you're watching this to make up points, addition property is the message you'll send to me to get those points back. All right, thank you guys. Have a great one.